Hey everyone, welcome back to this Ansys simulation software tutorial series. We're going to be picking up right where we left off in the video before this on Ansys Workbench. Today we will be covering Ansys Mechanical. So if you haven't watched the video on Ansys Workbench, I recommend that you consider watching that one before you continue with this one. But if you already know Ansys Workbench, then this video should work as a standalone as well. So the first thing we're going to do is open up the project that we saved in the video on Ansys Workbench. There are two ways to do this, and I will show you both. The first one is going to be to open File Explorer, navigate to wherever you stashed that tutorial system holding folder, open that, and double-click the tutorial system.wbpj file. That will tell Ansys to go ahead and start opening up. And then once that is done, it will open your project straight up instead of opening a blank slate for Workbench. This sometimes pulls up a little warning, and most of the time I just click OK and nothing happens. I think this is because I'm having OneDrive sync my files, but I'm not entirely sure, to be honest, and it's never caused me too much of an issue. The second way from your desktop to open up your project file that you saved before is to click the Ansys application, or go to search and then type Workbench and then click this. Then wait for Ansys to boot up and click the load icon. Then you will navigate through your files again to the same place where you have this stored, tutorial system holding folder. Double click that, and then you can either double click this or click it and click open, and that will open your project in Workbench. And again, you can click OK on the warning message. So I told you in the video on Workbench that these two would be covered under Workbench and the rest of them would be covered under Mechanical, and that's where they would get their checkmark from, and that is correct. So to open up Workbench, you could double click any of these. We're going to double click Model. Down here it will say starting Mechanical and switch from the green dot here to the red dot here. And then once Mechanical is open, and by the way, you can tell if it's open or if it's still loading by hovering your mouse over any button, and if it shows up the little gray box around it, then you know Ansys Mechanical is open, and if not, then you know it's still loading. Also, if you click it and you hear the annoying, hey, wait a second, I'm still loading sound, then you know, go figure, that it is still loading. Okay, Ansys is loaded up now, and we can tell because when you hover your mouse over a button, it shows up the little box around it. So this is what Ansys Mechanical looks like, and before we start doing anything here, we're going to go over all of the locations to find buttons. So the ribbon is obviously the first. It just has buttons upon buttons laid out here, and you can switch to these tabs or use the scroll wheel to scroll through these tabs and find more buttons if you didn't feel like you had enough buttons already. And of course there is File, which is going to pull up buttons along the left side here, including Save Project and Save Project As, which are the same buttons that we saw under Workbench up here. They do the exact same thing. There is this window across the left, which has outline and section planes and details at the moment. There is the graphics window, which is going to show the geometry that we're working with, and there's a lot of buttons located here in the graphics toolbar. And finally, there is the status bar across the bottom, which is going to show what units we're using. Lets us open the messages pane, and also will display a little loading bar when things are loading, and a little red square that we can click to stop it if we want it to stop, because it's going to take a few hours and we need to adjust things before it continues. You'll also notice that the geometry that we created in Discovery is here in the graphics window because it was saved under geometry. So Model is now going to be using that geometry to create our simulation. There are also a few miscellaneous buttons at the top. This one will let you minimize and open the mechanical page. This one will let you save your project the same way that this button will. This has some more options. This right here is just saying that this tab is context, and that means that whatever you have selected, it's going to pull up buttons for that. So if we select geometry, the context tab will change to geometry. If we select coordinate systems, context will change to coordinate systems. This is not a button in itself, besides the fact that if you click it, it will pull up this tab. There are also buttons on the right, the quick launch, which will let you search for something like section planes, which will pull up all the buttons for section planes that you could want. There is the options button. There is the Ansys Cloud button and the Find Help button, and this will let you maximize or minimize the ribbon. It's important to note that almost everything that you need to do to set up and run a simulation can be performed by either finding a button up here in the ribbon and clicking that, or by right-clicking something here in what we call the project tree, because each thing has little branches. That's why it's called a tree. You can right-click something in the project tree, and then that will pull up the right-click menu, and you can find the same button from the ribbon over here. I prefer to use the right-click menu because that's how I was taught to do it, and I frankly didn't know much about the ribbon at the time. And it's also a little faster, but there are some things you cannot do in the right-click menu that you can do in the ribbon, and the ribbon has all the buttons displayed very clearly, so that's very useful as well. Throughout this video, we are going to be doing everything using both buttons from the right-click menu and buttons from the ribbon so that you can get used to both, and you can use whichever one you like in the future, or so that you can get used to both, and then you can just pick whichever one you like best, or maybe use a medley of the two. So firstly, like we did for Workbench, we're going to mess with all of the windows just to see how that works before we start clicking all the buttons. You'll notice the same buttons here that we saw in the Workbench with the addition of the little window button, but if we start from left, we're going to see that they do slightly different things this time. This one will now let you select what you want to see in that individual window. This one doesn't have any of these options, but under Outline, you can hide the tree filter, which is that little search engine. Or you can hide the tree filter options, which are the options for that little search engine. So that's useful to know. You can float this, which lets you move it around, and you can dock it once again, but it's going to dock it in a weird place. I'll get to that in a second. For now, let's go float this, put it right back. You can hide it, and then it's going to disappear forever, and you can hide this, and you can hide this, and now all of your windows are gone, and that's kind of a problem if you want to continue running your simulation. So if you end up hiding all your windows and you need them back, you can get them back by going to the Home tab to the right under Layout, which lets you manage your layout, and then click Reset Layout. That is going to open the worksheet, but you can click this and click Hide. This button is it's going to hide it, but it's going to hide it on the left here in a little tab form. So you can click that and that'll open that up, and then you can click somewhere else and it'll switch from outline back to details. And you can do this to both of them. Now they're both hidden and you can select each of them or hide them. So let's put these back the way that they were using the little pin icon. There's also the maximize button, which makes this fill up whatever window slot that it has selected. There are essentially 3 window slots, one on the left, one in the middle, one on the right, and we'll get to that in a second as well. And then you can restore it back to its normal size. This, you can see, will make this fill up here, and then you can click this one, and that will squish outline and fill that up with details. And of course, you can close things using the X button, which will close it, and then you can use reset layout to get them back. because hide and close are essentially the same thing. So let's talk about floating things around. You can click float, and now your window hovers around just the way you would want to if you were on a Windows desktop. But you'll notice that there are several different spots that you can dock it that start showing up as you start to float it around. So let's just start messing with them. You can dock this here. Now that's to the left of details. You can float it again, and then you can go and dock it over it. So now instead of being in with details, it is completely replacing it, and the two can be selected using a little tab selector down here. You can float this again, and then instead of replacing it, you can put it in the same window but on the top, float, then in the same window but on the bottom, float, and you can put it in the same window but on the left, which varies ever so slightly from docking it here. And you can dock it in the same window but on the right. I'm going to tell you at this point that you don't need to click float every time you want to float something. You can just grab it and pull it, and now it is floating. You can also dock it up top here, and now you can see details has been squashed as well as the graphics menu, but you can grab this bar and you can start to adjust how that works. And I should note that you can also do this for windows that are together in their little window slot, and for how wide a window slot is. Window slot is a term that I've come up with. It is not an official term. I'm not actually sure what the official term is, but it's a good descriptor. So you can replace this, and now they can be selected with tabs here. You can grab this and, oh dear, it doesn't want to come out. Float. And you can dock it on the left side of this, or on the top, or on the bottom, or on the right. And you can also dock it down here, and you're going to get this nice little bar that you can pull, which I should note also does appear here. The difference between docking this here and docking this here becomes apparent because you can see that this is filling the entire width of the screen, and these two are squished together, compared to here, now it's only filling this much width of the screen, and this is where the two appear. And this is a similar pattern when you're docking it in other places. For example, docking this here, and then we can pull up another one by clicking section panes, dragging this out, and now we can put two here and one over here, compared to if we docked this on the left side. Now it's two here and one here. So there is a variety of options for where to dock things. You can close section planes. And of course, you can dock it on the right. And if you want to open section panes again, you don't need to know what section panes does right now. It's just another window. That's all that matters at the moment. You can see that you can dock this here, and then you can grab outline and you can either dock it to the right of those, or you can dock it with this one to the right of this one, and now it's too wide this way and too tall this way. And there's just plenty of options for you to mess around with how you want to dock things. So if you feel like adjusting how your windows look when you open Ansys Mechanical, you have plenty of room to do that. But I honestly just prefer the default, so I'm going to click Reset Layout and Hide Worksheet. And I'm going to drag this over here so that's about as wide as the words are, and so I can access my geometry as much as I want to. And I just leave it like this, and honestly you don't need to change much around, but it's good to know that you can move things around, because I didn't know that for a long time, and that could be rather useful. One last thing is that you can grab what we call the graphics toolbar, which are the buttons that are used for the graphics window here, and you can move this around. And it doesn't dock anywhere except for in the graphics window, here along the bottom, or along the left, or the right, or the top, which is where I prefer it to be, just as the default is. The status bar along the bottom, however, cannot be removed. It is permanently fixed at the bottom of the screen, where you can find your buttons to change whatever units you're using and to access the messages window. Now let's talk about all of the buttons for viewing the geometry that we have here in the geometry window. First, the scroll wheel. Nice and simple. You can scroll in and out to zoom in and out on your geometry. It's worth noting that when you scroll in and out on the corner or in the middle, it is not going to change. Some CAD softwares will zoom in towards the mouse, making the mouse the point of reference around which it is zooming, but Ansys always keeps that the center of the screen regardless of where your mouse is placed when you are zooming. Before we talk about how to view the geometry though, let's talk about each of the items that occurs in the graphics window. First of all, there is this little tree-like item up here. It's not displaying much right now, but it will display more in the future when we're looking at results, and it's useful. And it's useful also to note that you can just move it around if you need to move it around. I'm not really sure what it's called, but let's just call it the info box. There's also your version and Ansys displayed here so that if you take a screenshot, Ansys will get some credit because their name will appear in the screenshot. There is the scale indicator here, so you can see the distance from here to here straight across would be 9 millimeters. And there is the axis indicator down here. This can actually be clicked to show your geometry from any angle or from an isometric view, which is what the blue sphere does. You can view it from positive y, positive z, or positive x. And if you hover your mouse, there are actually 3 invisible 3D arrows that you can click as well. That's useful to know. And you can always click the blue sphere to get back to an isometric view. The middle mouse button can be used also to rotate the geometry. So instead of scrolling, hold down the middle mouse button and move your mouse around. This will rotate your geometry. There is no fixed point. It's not viewed like a globe where the north and south poles are always fixed on the top and the bottom. It just rotates freely. You'll notice that if you click the middle mouse button on empty space, it's going to rotate around the center, the geometric center of the geometry. But if you click on part of the geometry, it will rotate around that point, leaving that fixed in space. So this can be useful to move your geometry around just slightly sometimes if you're trying to get a better view. But the best way to move your geometry, of course, is to hold Control and then use the middle mouse button. This will pan the geometry. So you can release Control to rotate your geometry, and then you can hold Control to pan your geometry. And then you can scroll to zoom into a specific part of your geometry. Beyond the middle mouse button, the left mouse button can be used to select things. With the rotate tool selected, left clicking will move the point that is being used to rotate the geometry. But if we use the select tool, left click will start to select things. And right click can be used to zoom in on your geometry. It will zoom in to whatever window you highlight with your mouse. This can be very useful to quickly zoom in on a specific part instead of having to pan and zoom and pan and zoom and pan and zoom. And of course, there is the right click menu. This can be used for several things, but the things that we need to know right now include isometric view, set and restore to default, which will let you set the default view for your geometry and then rotate back to that view. For example, if we wanted to make this our default view, then we can right click and click set and restore to default, which lets you set the isometric view bubble at a different corner of the geometry. For example, we can rotate to this view, then click set, and now instead of the isometric bubble being around here, it is around there. And if we want this restored to default, we can simply click restore to default. And there is the zoom to fit button, which will zoom the geometry from way out here to fit your screen, or zoom to selection. So if you have this face selected, you can zoom to selection and that will fill up your window. These two buttons can be useful if you lose your geometry or if Mechanical opens and you cannot find your geometry, like if you're zoomed out way too far or if you're off to the side. You can use them to come back, but sometimes they don't always work. So I recommend just be careful. Don't lose your geometry. Don't do anything funny that's going to make it hard to find again, because sometimes it can be surprisingly annoyingly hard to find again, and that will slow your work down for no good reason, really. So just be careful. Don't lose your geometry. And of course, we have the graphics toolbar up here at the top, which has plenty more buttons for us to use. This button will let us go back to whatever view we were at and then go forward again. It's essentially like undo, but instead of undoing, it is going to switch between views. This will let you see the geometry with shaded exterior and all of these lines, or remove the lines. This button will let you display it simply as a wireframe, which means only lines, no faces, and you can see right through it, or not. Let's go back to isometric view. This button is grayed out right now, but it can show the model's mesh, which is where the model is broken down into a bunch of tiny little elements. But we do not have a mesh generated at the moment, so this button is not going to help us right now. These are a couple of tools. The rotate tool, which is what we were using before. You can see the little swirly rotation icon. This will let you rotate the model instead of using middle mouse button with left mouse button. And as you saw before, you can click to change the point of rotation and it will zoom to that. This is the pan tool. So instead of holding control and middle mouse button, now you can use left mouse button to pan around. But it is much faster to use control and middle mouse button instead of these tools. However, if for some reason you're using your laptop and you don't have a mouse, these will be your only way to perform these actions, so that is useful to keep in mind. Rotate also has two different options. Frankly, I'm not sure what they do, and I don't think you need them right now. You can just select the tool as is. There is the zoom button as well. This will let you use left mouse button to zoom in and out by moving your mouse up and down after holding left mouse button. There is the box zoom, which instead of using the right mouse button, will let you use the left mouse button to do this action. There is also the zoom to fit and zoom to selection buttons, which we saw here. There is also the select tool, which is very useful because that is the default. So if you're ever stuck on one of these and you don't know how to get back to just your regular mouse, then this is what you're looking for. Select and then single select. This will let you select a face or an edge or a single point, vertex. And if you triple click, it will let you select a body, and you can continue selecting bodies and not edges or faces or points until you click an empty space, and then it will reset that. If you click a face and you hold down your left mouse button, then as you drag around, it will continue to select only faces. If you select a vertex and then you hold down, it will continue to select, excuse me, if you select an edge and you hold down your left mouse button, it will continue to select only edges until you release the left mouse button. If you select a point, vertex, and you hold down, it will let you continue to select only vertexes. If you want to select multiple kinds of things or multiple things, and you realize that left clicking and then left clicking another thing is not going to work, holding down Control is what you're looking for. Left click, hold down Control, and you can select multiple entities and multiple kinds of entities. If you want to select multiple things at once, what you're going to need to do is hold Control, and then you can select them. If you just select and then select another thing, that's not going to work. You have to hold Control to select multiple. However, this is only going to let you select multiple of the same kind. You cannot select an edge and hold Control and then select a face. That's not going to work, but you can select multiple edges. Also note that when you left click something, this little button appears, which lets you select the body that that is connected to. That may be a little bit faster than triple clicking, and you'll note that this also switches you to selecting bodies until you click into empty space, the same way that triple clicking does. We've been using Smart Select this entire time, and that will let you select different kinds of items, edges, faces, or points, but you can change this so that it will select only one kind of those if you want. So with the vertex selected, you cannot select faces or edges, but you can select vertices. With the edge, you cannot select faces, but you can select edges, and you can select edges through objects. That's rather useful. So I can select the back edges of this cube without ever having to rotate my view. With the face selected, you can select faces only, no edges, and no vertices. And with body selected, you can select bodies. You can also change your mode from single select to box select. So if I go to box select and then select vertices, then I can select all of the vertices in this box, which is a whole lot easier than trying to click each one individually since they are so small. There's also these options, but these only appear sometimes, and they're kind of niche in their use. So box select and single select are your best bet. You will realize that if you want to select a face and you have box select on and you just click it, nothing will happen. Sometimes this is annoying because you're trying to select something and no matter how many times you click, you can't figure out why it won't select it. This is a good time to go check and make sure that you have single select and not box select on, because that can be really annoying sometimes. You'll also notice that if I select, say, right here, we get this little layer selector, if you want to call it that, right here, that will let us select different layers. But what are these layers? These are, if you imagine a line coming straight from your eyes and straight through the screen, through the geometry, it will let you select each face that the line would go through as it was passing through the geometry. So the back one, you can see, is going to be this face. This, if you go back to the view that you selected it from, this little crosshairs is going to remain in place the entire time. But that's just because we're looking through this direction. If you select this outer face and then pan around, you can see that this crosshair is clearly on this face right here at about the lower left. But if you select the back face, you can see that it is now on the bottom right corner of this back face, even though if we go back to isometric, it looks to be in the same place. So all of the faces that this is going to show would be this face, and then the side face of this box, and then the side face of this box, the bottom face of this box, the top face of this box, and the back face of this box. So this can be useful if you don't want to slice apart your geometry to see everything. You can just select and then the pane selector will show up. This layer selector can only be found when you use these options, but not when you use the Smart Select option. So it's worth noting that you can also do this for the vertices option, but this is going to be much, much more niche because the odds that multiple vertices align in a line through the screen is going to be very low unless you are using an isometric view and isometric objects like perfect cubes, which just happens to be what we are using right now. So you can see that this little point right here aligns perfectly with this when we are using an isometric view. And the same thing happens for edges. This edge is going to be right here. It's going to be the back one right here, which lines up with this one when we are using an isometric view. So just bear in mind that this can come in handy sometimes, although it is not used that much as far as I'm aware when you're actually setting up simulations. Next, there is the clipboard option, which can come in really handy sometimes. This will let you select multiple faces or edges or whatever, and then add that to the clipboard. And then from there, you can deselect them, select the clipboard, and now you can select the items that were in your clipboard instead of having to select them again. Or you can deselect that and then click Add Clipboard to Selection. So if you also had this face, you can click Add Clipboard to Selection, and now instead of replacing your selection with the items in the clipboard, it will add them to it. Or if you want to select all of these, and then you can click Remove Clipboard from Selection, and that is going to remove whatever you had in the clipboard and only leave everything else. You can also, let's select these four faces. You can clear the clipboard. Let's add the selection to clipboard. And then let's add these two faces to our selection and click Remove Selection from Clipboard. So instead of removing whatever was in the clipboard from what we have selected here, we're removing what we have selected here from our clipboard. So if we click Select Items in Clipboard, that only leaves these two because we removed these two from the clipboard. This can be useful when you have to select geometries and then add that to a mesh or add that to a force or whatever. That way you don't have to keep redoing things, or if something's hard to access, then you can just systematically select things instead of having to redo it every single time. And you don't really need to know what the rest of these buttons do. Lastly, now that we know how to select items using our selector tools, if you select a body and then you right-click an empty space, you can see that there are now these 5 options: hide body, hide all other bodies, filter tree based on visible bodies, suppress body, and suppress all other bodies. This one you don't need to know. Please do not click this button. It's not really going to do anything, but it's kind of confusing. If you click it, then this is going to pull up and you can see there are going to be a few items removed from the tree, and sometimes you'll be looking for something in the tree and you'll open it and you'll see it's just not there. It's just not there. Where did it go? It can't possibly have disappeared. And that's because when you click this button, it's going to add some things to the search engine here, and that is going to like remove items from the tree, and that's weird. So just click clear search and that will put everything back in the tree. Beware, sometimes if things are missing from the tree, this can be why, and this button right here is going to be your friend. The other buttons will let you make things disappear. You can right click and then you can click hide to make items not show up if you're trying to access the things behind them and you don't want to use the little level selector that shows up here. You can use show all bodies again to show everything once you've hidden something. If you hide it again, you'll notice that you can invert visibility, which is going to show everything that's hidden and hide everything that is shown. And if you show all bodies, you can select something or maybe two things, and you can select hide all other bodies. And that is only going to show what you've selected, and it's going to hide everything else. And invert visibility will continue to work as normal. So these are a few options if you're trying to get deep into your model that has multiple layers to select something hiding there, and then only use that for your simulation. These tools are your friend. There's also the option to suppress. Now, from the graphics window, that's going to look exactly the same. It's going to look like it's just hidden and you can get it back, but the light bulb icons are not going to help you. Unsuppress all bodies that's going to get it back. Let's suppress these, and then unsuppress bodies, that will show them again. You can also click something or click multiple things and click suppress all other bodies, and that is going to suppress everything else. There is also an invert suppressed body set, and that is the same as invert visibility, and unsuppress all bodies will show everything again. It kind of seems like this is doing the exact same thing. You can either suppress it or you can show it. What's the difference? It's doing the same thing. The difference is a hidden object is only hidden in the graphics window. If you click geometry right here, you can see all of the objects that are part of your geometry. And a hidden body is just going to have a little grayed out check mark. So if I click this, or if I click this, you can see that's the same thing. And if I hide it, it's going to have a grayed out check mark. And then if I show it, it's going to show up again. But the difference is that if I suppress a body, not only is that going to change it from a grayed out check mark to an X mark, Ansys is actually going to pretend like this does not exist in the simulation. It's just going to completely ignore it when you add forces or when you add supports. It's going to act like it's just not there in the actual simulation compared to just what we're looking at. If a body is hidden when you're looking in the geometry window, it's still going to simulate on it. But if a body is suppressed, it is not going to simulate on it. And that is the difference. Now that we have covered where all the buttons are and how to view geometry in the geometry window, we are going to go over everything in the project tree. This is where all of your simulation setup and running action is going to happen. And ultimately, all of these buttons up here and the graphics window are just to help you get the tree set up so that you can run a simulation. To do this, we are going to actually run a simulation on our geometry here because that's the best way to explain what everything does, and it's kind of weird to explain what it does without actually doing something with it. So we're going to start at the top and go through. First is this little project bar right here. This is just our project right here, and everything is going to fall under it, and you don't really need to know anything about that. Model A4 is going to be the same thing as model right here. And essentially what that means is everything before static structural. So the geometry imports, the geometry, materials, coordinate systems, connections, and mesh. All of those need to be set up, and once that is set up, it's going to put a check mark under model. So let's go through that. Static structural, under that, obviously that is our static structural, and why doesn't that appear up here instead of down here? It's a little bit convoluted, but it will make more sense when we make a multi-simulation project in the video at the end of this course. This is where your setup is going to fall. It's going to fall under here and above solution. Solution is going to be the solution tab here, obviously. And then under the solution tree item, there are going to be your results, but none of them are here right now. So there's not really anything to link to results at the moment. So first, let's go over the setup using all of these one at a time and in order. Geometry imports, you don't need to know anything about that. Geometry. This is going to show everything that we've been talking about over here. You can select each one and you can see it selected in the graphics window. You'll note that if you select materials and close this, everything is blue like it was before. When we were using the graphics window, everything was blue, but when you select geometry, everything gets a different color. That's fine. These colors are not related to anything at the moment. They're just used to differentiate the different objects in your geometry. So don't fear if that changes colors. That's not really going to affect anything at all besides what you're seeing. From the Geometry tab, you can select each individual solid object that is in your geometry. Sometimes it's just one, but we've set this up so that there were 4 of them. If there were not 4, then perhaps you misclicked something when you are doing the discovery portion of the Workbench video, so you might want to go back and review that before you continue. From the geometry tree item, you can also hide and show, suppress, and unsuppress just the same way that you would have if you selected the item here, except now it's all displayed. So when you hide a body using the body selector and then hide a body, you can still see it over here, and that can help you show each one individually. You can also click and then click F2 to rename items, or you can click and then, or you can right click and then click rename, which is right here, F2. That way you can differentiate between each of your bodies. You can also select multiple bodies using the body selector and then click create named selection, or select them here and then click create named selection. This will let you make a name for the selection, test selection. Okay, and then that creates the named selections tab down here, which will let you select that, and that you can do things like select items in group, or select that and then click add to current selection, and you can remove from current selection. And this is essentially the same thing as the clipboard, but it's a bit more definite in that you can use this to suppress items, and it just permanently stays here where the clipboard can be overwritten, and then you lose the other things that were in the clipboard when you overwrite it. You can also right click and delete this, and then you can delete the name selections. The only thing that you need to know when you click this about the details panel, the only thing you need to know when you select an item about the details panel here is the suppressed item under definition and the assignment item under material. Suppressed will let you suppress or unsuppress this, and you can see that if you suppress it up here, then under details, suppress will now say yes, whereas if you unsuppress it, it says no. And assignment will let you change the material of the item. We can see the 3 materials that we had set up under Workbench: structural steel, stainless steel, titanium alloy, and tritanium, which is a make-believe material that we just made up. If you click the P, that will do the same thing that we saw under engineering data under Workbench. It will create a parameter set here that wasn't there before, and you can see the parameters, which will let you change the material. So structural steel, you can see we have clicked the P, so now it's parameterized. The assignment is structural steel, and we can't change that from here, but we can change it directly from here to titanium alloy. And now if we click off and click back, we should see that it is titanium alloy. It's not actually showing up as titanium alloy here, but its material has been set to titanium alloy when the thing is run. And if we unparameterize this, we can see that the parameter set is gone and it is no longer in use. So that can be useful if you want to run this with this individual object as one kind of material and then separately as a different kind, but you don't want to set up a completely different simulation for each one, and you have a couple other specific things you want to change between each run. You can parameterize them, and that will let them all show up here, and that can be very useful for multiple runs. That's everything you need to know about the geometry tree item. Speaking of material assignments, we can now see the materials tab. If you click this, you're going to see all your materials here, and then their engineering data listed in this window, engineering data, material view. but you don't really need this. You can close that out. If you click structural steel, it will do the same thing. You can close that out. Basically, everything you need to know about this is if you right click on a material, you can click Create Material Assignment. This will create the structural steel assignment under the Materials tab. Then, under the details of this material assignment, you can select which geometry is going to be used for this assignment. So let's click the top left and then click Apply. Then material name is structural steel because that's the way we created it, since we created it by right-clicking structural steel. And now this body will be set to structural steel when the simulation is run. You can right-click a different one, and that will create, for example, if you right-click stainless, you will get now a stainless steel assignment. And you can select a different geometry and click Apply. You can, in fact, change which material is being assigned here, and that will change the name, of course. And you can change it back. If you right-click Materials and then go to Insert and then Material Assignment, it will create a blank material assignment that will let you select a geometry and a material name. So let's make a material assignment for each of our bodies. So now we have the top left is structural, top right is stainless, bottom left is titanium, and bottom right is tritanium. Whichever one is selected at the moment is shown in red, but since we have stainless steel also shown in red, I'm going to click that so that kind of cancels out, at least as far as the way we're looking at it goes. Now, if you remember, if we go back to engineering data under Workbench, stainless steel is red, which checks out. Stainless steel right here, it's red. Structural steel is blue, then green, then yellow. Structural steel is blue. And then we have green and we have yellow. That's because we selected those colors under engineering data to make viewing that easier. These colors are only going to show up when you are looking at the materials tab specifically. If you're looking at geometry, they're going to get random colors. If you're looking at mesh, they're going to get random colors. But if you're looking at materials, they're going to show up in this way. The two ways to assign materials are either to select the item under geometry, go to material, and then select the assignment, which is now grayed out since we have created these assignments, or you can create the assignments. Both ways will work. I prefer to do it under materials just so I can differentiate because it's easier to see this than it is to select this and go to see details. It's just nice since they're already two different tree items. It makes sense to use both of them instead of leaving materials unused. Now is also a good time to give a bit of commentary on the details pane down here. When I first learned to use Ansys, I thought that the details pane was just a sort of weird location for the buttons that I needed to push when I was creating a tree item, and then after that it was obsolete. So let's delete stainless steel. I thought that basically all it was is you create a stainless steel material assignment or something else. This is where you'll find your buttons highlighted in yellow. You click that and then you're good. And the only purpose of the details pane was to help you find the buttons that you needed to click when you were creating that tree item. I realize now that it is actually more than that. Details is telling you all of the nitty-gritty details about every single item that you can select in the tree. So if I select stainless steel, I can see all of the material properties that I created under engineering data. And I can also see a bunch of other items that frankly I really don't know what they do, and I don't think I need to know what they do at the moment. And I can see the geometry that has been used for this selection. So instead of this being where my buttons are found, I create it and then I need to set the details of the assignment using the geometry detail, and it's more about editing the details, which is using the graphics window, than the thing being in the graphics window, and then I go from the graphics window to details just to find buttons, and then I leave and I don't care about it after that. That is, I think, a better way of looking at the details pane, and that really sets your mind towards, oh, this is where the details are. If I need to find some, I should go look at the details pane instead of it just being this weird place that you don't really use. So that's just a bit of theory that you should keep in the back of your mind as you are using Ansys. Coordinate systems, you can ignore coordinate systems. Connections, you can also ignore connections. The last item under setup is mesh. Mesh, you can see, does not have a plus because we haven't actually done anything to it, but this is how we're actually going to break down our object into a bunch of little objects so that Ansys can perform finite element analysis on our object and get those results that we want. Essentially, everything you need to know about mesh is that you right click and then you insert, and then you can go to sizing. Sizing will let you select your objects. I just always select all of them, and then let you set an element size. So that's going to tell Ansys how large you want each individual element to be. And then from there, you generate your mesh, and that's pretty much the meshing process on a beginner level. It's important to know that meshing is incredibly complicated. You can do an entire PhD on meshing if you wanted to, and it's very complicated stuff that I don't know much about. It's not the best practice to think that the best way to get a really good mesh is just to make the elements really small by using a smaller sizing. That is not correct. There is a lot more to it than that, and you can waste processing power if that is all that you do. But at the moment, that is the only thing that you need to know how to do. So find an element sizing that works to where if you go smaller than that, the results do not change when you run the simulation. And then just use that sizing and that's fine. But realize that meshing can get a lot more complicated, and simply using a smaller mesh sizing is not the essential solution to the problem, but it's good enough for what we're doing right now. After you have selected your body sizing, let's set this to 1 millimeter. And since we know that these are 10 millimeters across, since of course we created them that way when we were using Discovery, and we can in fact measure them using our little measurement item right here, 10 millimeters across, we know that there should be 10 individual 1 millimeter cubes as we go across the geometry. But in order to have Ansys make this geometry, we need to right-click Mesh and then click Generate Mesh. This is going to make the computer actually start processing for a minute, and this can take a long time if you have a very big geometry, or it can take a short time if you have a really simple geometry like this one. So if you click Generate Mesh, it should take 15 seconds, no more than a minute. Ours is already done, as you can see. And now it's created a bunch of little 1 millimeter cubes across the geometry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, just as we expected, all around each cube. So now that our geometry has broken into a finite number of elements, Ansys can perform finite element analysis. And you can close the mesh section. If we go back to Workbench under Model, this no longer displays a lightning bolt. It displays a little circly green thing, which is progress. It's not complete yet because we haven't solved the rest of this, which is what Ansys wants. But after we do that, everything should show up as a check mark. Before we move on, let's continue experimenting with this body sizing. If we set this to 0.5 millimeters, then right-click Mesh and click Generate Mesh, it's going to generate us a new mesh. we can see here under the little info box that obsolete mesh is pink. So this was the previous mesh, and now that we've changed the sizing, it no longer accurately represents what Ansys is trying to do. So it's not really going to matter because it's essentially outdated now that we've changed that. So if you click Generate Mesh, Ansys will start solving again. Now we have a mesh that should have 20 blocks across. This is a much finer mesh than the previous one, whereas the other one, compared to this one, is more coarse. Coarse and fine are the two words that are used to describe how small the elements are in a mesh. We can further refine this by going to 0.25 and then right-clicking and clicking Generate Mesh. This one is going to take a decent time longer, although not that long, at least on this computer. And now we should see 40 across the width of each cube. And this is a very fine mesh compared to the 1mm mesh. It is 4 times more fine, I believe. Of course, a finer mesh is going to take much longer to simulate, as well as much longer to generate than a coarse mesh. So for the purposes of this video, we're going to use a 1mm mesh, and then that will be what we will be simulating on. But if you are doing an actual simulation for an actual project, I would recommend you solve it on a coarse mesh just to get a general idea, make sure the simulation is set up right, and everything is making sense. And then once you're confident in that, make the mesh finer. Generate the mesh before you, there is a way to just right-click model and then solve, and that will solve everything, including your forces and the results that you want, not just the mesh. So that's going to do the mesh and then move on. It's better if you right-click and generate mesh, make sure the mesh is good, and then move on to the rest, because otherwise you're going to have to stop it, and it's going to reset all your progress, and it's just going to have to cut it in the middle, and that's not as good as if you just solve this before you go ahead and move on and make sure that's good. So, like I said, solve it with a coarse mesh, and then make sure everything makes sense. Then go to a finer mesh, make sure the mesh is good, and then solve the rest so that you can get very precise results once you make sure that everything is set up correctly. So that's all for mesh, and you can close that, and we'll move on to the rest. There are essentially 5 things left to add to this simulation before we run it. That would be forces, supports, and then we want to evaluate results for stress, strain, and deformation. Forces, results, stress, strain, and deformation. Those are the basics for a good FEA simulation. You may need different things if you're doing a more complicated simulation, but at the moment, that's all that you need. So if you right-click Static Structural, you can go to Insert and then Fixed Support. This is going to hold down a part of your model. If you don't hold down a part of your model and you just apply a force to, say, the left side, a pushing force to the left side, then the model's going to fly off to the right and it's not actually going to deform any, and Ansys is going to throw a fit because it doesn't understand what you're trying to get it to do. So if we wanted to apply a pushing force to the left side of the model, then we would need to fix the right side of the model, or maybe we want to fix the top or the bottom or one of the other sides of the model, and then we can apply that force, and then Ansys will be able to evaluate what happens when that is done. So let's click Fix Support, and let's just go to Geometry, select Faces, and then make sure Single Select is on, and then select, hold Control, select, and apply. Now we have fixed these two faces. You can see the fixed support has been added under static structural, and these two faces are fixed in place. That is quite literally all there is to adding a support. There are no other items that you need to select under details, and there are very few items under details at all. The types of supports that you need to know about are fixed support, which is simply as if it was glued to a solid object that is not going to deform at all. There is frictionless support, which is as if it is just resting against that surface. So if you applied a force like this, then it could slide along the surface, but if you applied a force like this, it would put it under compression. And compression only support, which essentially does the same thing. I'm not sure what the difference between these two is, but as far as I'm aware, they essentially do the same thing, and that's worth knowing if you want to evaluate an object when it is compressed like that. So with fixed support done, we can right click, go to Insert, and then go to the Forces section. Force is essentially the only thing that we're going to need to use. So click Force. We fixed this side of the object. Let's apply a force to this side of the object. Select your geometry. Under the geometry detail, click Apply. Type define by. Define by is actually useful. Type you don't need to know. Define by is useful though. This will let us either define the direction by using an edge that is parallel to the direction of the force that we want to apply, or we can click components, and now the force will be applied by using the x, y, and z components of the force that we are applying. So let's do both. First, vector. We'll type in the magnitude. We're going to use 1,000 newtons. And then the direction, we want it to be applied towards this. So we're going to select this edge right here, and now it's using that as the vector. This will show up so that we can change which direction, because obviously if we select a line, there are two different directions that it could be applying that in. With this one supplied, since we want to put this under compression, with this one selected, excuse me, we can click apply, and now we have our force defined. Alternatively, we can go to components, and we can see that we want to apply this in the x direction. So we're going to set the x component to 1,000 newtons, and everything else is left as 0. And now we get the exact same result. Our force is defined, and it will simulate both of these the exact same way. Now, this, of course, is the setup. Whereas previously we were setting up the model, now we have set up the setup. If we told Ansys to solve this at the moment, it would solve everything. Actually, let's just go ahead and do that. We're going to go to Home, and then we're going to click Solve. Ansys is going to create this little status bar. You can pause, or you can stop the model, or you can click the loading bar to pull up this little window, which just disappeared. That shows you what the progress is in more detail. Now, everything has a check mark, except some of these have a little slightly different icon. If you click this little blue arrow here, you can read what exactly is going on. It wants us to refresh or update because something up here has been changed. So let's click Update Project. This is going to make this red, and it's going to take it a minute. Okay, and after about a minute, you can see that everything should have a check mark. This is probably just because we were messing around with the engineering data before. Otherwise, we would have gone back to Workbench to see that everything had a check mark. So, as I was saying, everything has a check mark. We've got the model, which is everything here. We have setup, which is our forces and supports. And we have solution, which is contained in this solution information file right here. And we don't actually have results. So it puts a check mark because we didn't actually ask for any results. So there's nothing to do, and so it must be done with it, right? So we could ask it for results though, but suffice to say, everything has received a check mark except for results right now, essentially. If you click solution information, you get this very fun file which says a lot of things, and we're not really sure what it means, and we are not actually going to be using that anyway. So let's ask Ansys for some results now that we have everything else set up. If you right click solution, you can go to insert, you can go to deformation, stress, or strain, and just click the first one that shows up. Total deformation, strain, equivalent von Mises strain, and then stress, equivalent von Mises stress. Now, if you go back to Workbench, you'll see solution still has a check mark. The model was solved, so it figured out what happened. But results, which actually takes that solution and then turns it into tangible results that we can see and that we can use for our project that we're working on, has not been solved yet. That one still has a lightning bolt. So even though the model is solved, we haven't gotten the results, which is why they are two separate tabs. So fortunately, taking a solved solution, which has this little check mark, and turning that into results is nearly instantaneous. If you click solve, it's already done. And now results once again has a check mark. Before I move on, there are two things that I want to discuss. The first is, at this point, your model is solved, your simulation is solved, and you should save your project before you do anything else. So you can click this icon, you can click this icon, or you can click this icon, and that's going to save your results for you in case something happens at this point, because sometimes these models can take hours to solve, and we don't want to lose everything now that it's finally solved. So it's just a good practice after it's done to go ahead and save that, as well as in case you decide you need a finer mesh, instead of solving again and then losing what coarse results you had, you save that, and then you at least have some results, and then if something fails, now you can try again, and you still have a backup to go back to. So once this is done, just click the save icon. Ansys will take a minute, and it will save it. It's throwing me errors right now, but that's not important. The important part is you save your model once you're done. And the last thing is, it can sometimes take hours for Ansys to solve these. I have personally left my computer running overnight several times for rocketry simulations. So it can be useful to go to settings, go to system, and then go to power and battery, and set the screen sleep and hibernate timeouts. Set the plugged in. Leave your laptop plugged in if it's solving overnight, believe me. You want that plugged in or it's going to die and you're going to lose all your results. Turn my screen off after 1 minute, and then just leave your computer there so your screen's not on because you're going to sleep. And then make my device sleep after never. So, and then this will let your computer continue running with your screen off while you are happily sleeping away. And don't minimize this settings window, just leave this open so that when you open your computer, the first thing you see is this, and you remember that you need to set this back to the default so that it doesn't fall asleep while you're in class, because that would be quite annoying. Now that our model has been solved, let's take a look at the results that it has evaluated it for and try to interpret those a little bit so that we can use those results for whatever project that you happen to be working on in the future, because that is, after all, the whole point of Ansys. So the graphics window here displays our model after it has been deformed, and with colors all over it that represent, according to this legend here on the left, what the stress, in this case, since we have stress selected, at any given point is. So you can see that right here at this red point, the stress would be about 14.455 megapascals. If we go to deformation, we can see down here the red means that this part of the model has deformed 0.0019 millimeters. This, of course, looks a lot more than 0.019 millimeters, and that is because this is not set to true scale. If you go up to this drop down under the Results tab, you can click True Scale. This is going to show your model as it would actually be deformed. You can also set this to undeformed, and then you can see that it's barely deformed at all. What we were looking at is the 5 times the auto scale. Here we have the auto scale, which is just bent slightly and gives you a sense for what's going on, even though the model has not actually been deformed nearly as much as it is showing. That just helps to give you a useful visual, and if that's not enough, you can always increase the scale. This little info pane here can still be moved around, the one that holds our legend. It also still shows the date, but here it shows what we're looking at, total deformation, and what the units are and what the timestamp by this point in the model is. A timestamp is just what time this is at when it reached this deformation. To see the deformation at different points in time, you can go to this little graph window here and click the play icon. This is going to take a second and create us a nice animation to show how it deforms over time. You can still change the scale and then click play. That's going to create another animation. And you can see that this is varying between 0 and 1 seconds because Ansys automatically assumes when we put in a single static force that that is going to be applied over the time of 1 second. So after that's been applied, this is what we have. You can press pause to pause this at any point, and you can press stop to return back to normal. The Details tab here also holds valuable information. We can see the maximum deformation, the minimum deformation, and the average deformation. And that is about all that the Details tab is useful for evaluating results. Tabular data is not particularly useful because we only have one timestamp, so you can close that. But if you had different timestamps, which you might be using for a more advanced simulation, then tabular data could come in handy. The remaining buttons that are useful for evaluating results would be to right-click the info pane. You can change this from horizontal to vertical. You can change what it shows. You can change the color scheme to grayscale or reverse grayscale. You can make it semi-transparent so that when you're trying to see the deformation, it's a lot easier to see than when there's no background. And you can reset this and put it back up in the corner. There are also buttons up here under display and section pane. That's about all you're going to need at the moment. This we've already discussed. This will change the scale. This will let you either see the exterior, isometric surfaces, which are going to be surfaces where any point on that surface is experiencing the same, in this case, deformation. If we went to stress, we can see this is a lot more complicated, but any point on these surfaces is going to be showing the same amount of, in this case, stress. You can see the contours with lines in them, or you can change this to smooth contours, which adds a gradient to the model. And you can show ISO lines, which is just ISO surfaces, but only the lines as they touch the edge of the model. This will let you see the model without the wires, the edges. This will show you the model as it is, but it shows you the wireframe of the original undeformed object. This will show you that, but instead of a wireframe, it is a transparent version of the original object. And this will show you like normal with each of the elements and their little wireframe around them. We also have maximum and minimum. This will show you the point of maximum, in this case stress. You can click this to disable it, and minimum stress. And probe. Probe is very useful. If you click this, this will let you, it usually takes a minute to load, but then it will let you see how much stress is at a given point on the model. So right here, we're going to be seeing 2.3 megapascals. Over here, 7.22, and over here 12.848. If you click, it will throw down a little tag which shows which node on the model that this was at and what the value was there. And you can throw several of these down just to keep that in mind, and you can take a screenshot, and that will let you see for future reference what the stress was at any given point. If you want to remove these, you're going to go to the graphics annotation window, which has showed up now that we've started using probe. And you can right click an individual one. First you have to left click it, then right click, then delete, or you can right click and delete all. If you close this window, and your nodes will, your probes will stay there, but now you can't delete them obviously because the window's closed. So if you want to fix that, you can just reopen probe, throw down a probe, and then now graphics annotations will show up again, and you can right click and delete all. So let's interpret our model a little bit here. We're going to go back to 5 scale. What we can see is that the model has deformed most on this corner, and it's starting to squish that way. The weakest of our 4 blocks, each of which had an individual different material, is probably this one, which was the titanium block. And that's probably because that one is squishing most. We should be able to tell that is the one that is the weakest. This one is probably the strongest, and if we'd have to guess, this might be the second and this might be the third, based just on how much they're squishing. We can also see that there is a stress concentration right here at the corner, whereas little stress is happening up here at the top. So if we were worried, that would be the point to be worried about. However, this is significantly lower than the yield strength of any of the materials that we had, so we should be fine there. It's not good to have a gradient this much that varies from green, yellow, orange, all the way to red in a single element. So what we might do is do this again with a finer mesh so that we get more accurate results, because something like this indicates that this is not as accurate as it could be. But for this example, we don't really need to worry about that. The last thing you need to know is section planes. This will let you slice your model up so you can get a good look inside it. Click section planes, click and drag a line, and that will slice right through your model. If we go back to undeformed, you can see that this has been sliced into each of its individual elements. You can see each of the individual elements here through the middle. And that just lets us get a good look at the inside of the model. You can throw multiple of these section planes down, and instead of removing more, Ansys is going to only cut out of the model what was cut out by both section planes. So instead of another section plane removing more, it shows more. You can see your section planes down here, which is right over the details, and you can select that with the little tab selector down there, and you can select and deselect section planes so that you can get a different look. You can create a new section plane here, edit the plane, which is rather useful actually because you can click and drag this along. That's very handy. You can rename it, delete it, or you can click this. This button will show whole elements. That's what it says, show whole elements. So basically, if there is an element and you can see just a part, even the smallest part of it, Ansys is going to show you that entire element. So if we align this like this and zoom in, you can see right here, there's just the slightest corner of this element. But if you click show whole elements, it's going to show the entire thing as a cube right here. In our case, all of these are cubes, and this looks like something out of Minecraft, but you're not going to have pure cubes for a lot of your models, so it's going to show some weird shapes. But this is just kind of useful if you want to view it in that way. Section planes has the same thing as probe. If you close it, the section plane remains, and if you want to get it back, you can just click this, it'll show up, and then you can right click and click the little X up here to delete your section plane so you can see your whole model. Congratulations, you just finished your first Ansys simulation. Everything should be good, and you can save this again if you've made any changes like section planes that you want to save into your model. You can go up here to images and then click image, and that will just take a snapshot and throw that down under here, which you can find later under files, and then you can save that, and that could be useful for the future. And that completes your first Ansys simulation. But the video is not over yet. Before we wrap up, there are a few other things that I want to discuss, and then we're going to go and do this all very quickly again using the ribbon instead of the right-click menu, just so you get some experience doing that as well. All right, so things I wanted to discuss. Number one, let's go again over each of these little icons so that you know what each of them does. The first is the green check mark. That means everything is okay with this part of the tree. It's done, and you can solve the model with that, or if it's a green check mark down here, that means that it's already been solved and you're good. There is the almost transparent little check mark down here, and that means that the object has been hidden. The X means that that part of the tree has been suppressed, and Ansys is going to go on pretending like that is not a part of this project. The yellow lightning bolt means that this part has yet to be solved. And if you click solve, you're going to see a green lightning bolt, and that means it is currently solving. In our case, that only shows up for a minute as it solves this, and then that should turn to a red lightning bolt instead of a green check mark because I changed my settings so you guys can see that. The red lightning bolt means that it tried to solve it, but it failed, and so you should probably go check messages and make sure that you fix everything, and then if you run it again, then that should work. In this case, what I did to get the red lightning bolt was I went into my solve processing settings and I re-enabled GPU acceleration, which I told you would throw errors, and this time it did. So we're going to change that to none. Click OK, and then we can click solve again, and this time it should go from a green lightning bolt to a green check mark. A general rule of thumb is that if messages show up, you don't really need to check on them unless they cause errors and you don't get the thing solved. So if it shows a red lightning bolt, you should go check messages, and you can double click these to pull this up, and that will give you a bit of a lead to try to figure out what's going on next. But if you get a green check mark, you don't really need to look. In this case, it says something about an MPC or a Lagrange multiplier, and we don't really need to care what that says or what that means because our thing was solved. If you're running more complex simulations, you may need to look at that, but for a basic beginner level, you don't really need to worry about that. Let's unsuppress this. Yes, and we're going to unhide this. And since this is now unsuppressed, we do need to solve it again. The last thing is to look at the mesh. If you go up here to the right, you can see the metrics display. This is going to show you how good each of your elements is in your mesh. You can click this and it will pull up the mesh metrics graph. Here I'm not really sure what it's displaying right now, but you can click the drop down. Yes, it's showing element quality. So element quality varies between 0 and I'm not really sure. And this shows you how many elements are of that quality. In our case, each of these metrics is going to show exactly the same on the graph because all of our elements are exactly the same. But if you were doing a more complex geometry, you would see usually, a concentration of 75 quality, and then there would be fewer that were lower quality, fewer that were even lower, and of course there would be some fewer that were higher, so almost a normal distribution. Dukhyun Patel has a very useful chart that shows you how much you want for each metric, what is the ideal. So I'm going to throw a link to that up on the screen here so that you can take a look at that. So the other thing you can do with the metrics is click controls. You can change which what the y-axis is, how many bars, what the range is, and you can select which kinds of elements it's showing. In this case, I suppose we have only hex 20 because that's what it's showing. These are different kinds of elements, so this would be a tetrahedron, this would be a pyramid, I think, I'm not really sure, and the rest of these would also be different. But that's for more complex meshing, and you don't really need to know about that. You just need to know you can check this, and you can go reference to Dukhyun Patel's chart and see if your mesh is good or if it's not. Okay, now let's do everything again, but we're going to use the ribbon. So let's go over to here, make sure our project is saved. This should go by much faster since we've already done this once. Let's click New to start a new project. That'll close Mechanical. So grab a static structural, bring it up here, double click Engineering Data. View. We need to reset workspace. Here we go. So let's go to Engineering Data, General Materials. This time we're going to get stainless and titanium, just the same way we did it last time. Make some titanium. And we'll just make things up like we did last time instead of trying to find the same metrics. Compressive tensile. Compressive density, how about 200 this time? Young's modulus, let's set this to gigapascals, and we'll give it 65. Poisson's ratio, 0.7. Make sure these are megapascals. I think we forgot to do that last time, which is why all of our titanium was really weak. So let's go 65, 70, 70, and 75. And that should be good. We'll leave the colors as they are. And what's wrong? It's showing a question mark. Titanium. What is it not like? Oh. Does it not like Poisson's ratio? That's interesting. 0.07? Does it like that? It likes that. Okay. Sure. It doesn't really matter at the moment. Geometry. Right click. New discovery geometry. Wait for discovery to boot up. I will also leave the geometry file down in the description if you need to access that, and it should be in the description of the Workbench video as well. So wait for Ansys Discovery to boot. Now that's open. Sketch is open. Let's view this from Z. Click the rectangle. Drag this out to here. Drag another one out to here. One more out to here. And one more out to here. Go to pole. Pan around. The same control and middle mouse button applies. 10, enter, no merge. Draw this one up, type in 10, enter, click this. 10, enter, click this, pull it up, 10, enter. That should be good. Close that. Now double click model. And you don't need to bother saving this project, so we won't bother with that at the moment. Now we wait for Mechanical to boot up. Okay, Mechanical is now booted up. So let's go to Materials, click that, go to Context, and we're going to click Material Assignment up here. select the geometry and click apply. And material name, we're going to go to structural steel. Let's create another material assignment. This one we'll use this for apply, and we'll go to stainless steel. Another material assignment, this geometry, and we will use titanium alloy. And our fourth, we will use this one and titanium. That should be good. Mesh, we're going to click sizing, geometry, left click and hold, select all of those. Default, we're going to change that to 1 millimeter and then click generate. We get the little green lightning bolt and now a check mark. Static structural, go to our context tab again. We're going to apply a fixed support here and click that, applies our geometry. Then force here, apply magnitude 1000 newtons. Direction, we're going to use this, and that's the correct direction. So click apply. Solution, we're going to go to deformation, total, strain equivalent von Mises, and stress equivalent von Mises. Then click solve. Wait for the computer to solve it. And there you go. We just solved it with slightly different values for titanium. And now you know how to do it with the ribbon, hopefully a little bit. I kind of sped through that. But once you know basically what we're doing, finding the buttons listed under the context tab should be fairly easy. And let's go ahead and take a picture of each of these using the images option and see if we can dig around in our files for a minute and find where that's listed. To do that, we are going to have to save the project as. Let's go to Ansys files. We're going to create a new folder. System number 2. Ding, folder, enter. I said we wouldn't save this, but turns out we are going to save it. Stag 2, save. Wait for that to save. Open files, Ansys files, system 2. This should be under files. I think it's DP0 global mech sys figures and images. Yep. And there's your images. Now, if you want to take these, you can drag them over to wherever instead of having to use the print screen function. This is rather nice. All right, that wraps up this tutorial on Ansys Mechanical. Hopefully you learned something. If you did, I hope you will enjoy the rest of the tutorial series. Feel free to move on to the next video, which will be on a cantilever smartphone example, which will be example 1 out of 3, just to get you a little bit more experience with Ansys. As always, may the Lord bless your engineering. Come visit us at LU sometime, and feel free to enjoy the next video.